Okay, let's just dive right in. Welcome to this explainer, where we're going to demystify the application of AI in medicine. Look, there's a ton of noise out there right now, so our main goal here is to separate the hype from what actually works in your ICU today. We're going to look at how these tools can dramatically accelerate your research and your daily workflow, but, and this is absolutely crucial, we're also going to draw a hard line around where your clinical judgment must stay in absolute control.
So here's our quick roadmap for the explainer. First, we'll cover the stakes in medical AI, then the core prompting framework, followed by AI and data analysis. After that, we'll break down ML versus generative LLMs, and finally wrap up with the human in the loop.
All right, Section 1, the stakes in medical AI, specifically the AMR crisis. Let's get into it. To really understand why we need AI, we have to look at the numbers. By the year 2050, antimicrobial resistance, or AMR, is projected to kill 10 million people annually. Just think about that, 10 million. That is actually more than cancer kills today. And India alone already carries a massive, disproportionate share of this burden, with over 280,000 deaths attributed to AMR every single year. This is exactly why our antimicrobial stewardship tools literally must scale right now. Every single day we're forced into this terrible trade-off, right? We either treat broad and risk resistance, or we treat narrow and risk totally missing the organism. And you already live this reality on every busy round. You know these diagnostic bottlenecks all too well. Sepsis mimics non-infectious inflammation. We suffer through these agonizing 1 to 3 day culture turnaround delays that essentially force our hand into using broad-spectrum coverage. And even when we finally get a positive culture, it can totally undersell the actual resistance. Now, every single AI application we're going to talk about today exists specifically to shrink those exact gaps, basically removing that frustrating lag between taking a sample and actually getting an answer. Moving right along to Section 2, the core prompting framework. Let's look at how to actually talk to these tools effectively. If you've ever gotten a bad answer from an AI, it was probably a bad prompt. The core acronym is your actionable blueprint here. It stands for context, objective, role, and expectations. So first, you provide context about your domain or target audience. Second, you state one clear objective, meaning exactly what you want the AI to do. Third, you assign the AI a specific role, tell it to act like a research assistant or maybe a biostatistician. And finally, lay down strict expectations regarding word count, tone, or format constraints. Let's see what that difference looks like in practice. If you use a weak prompt, something like, tell me about sleep and screen time, you're going to get a generic, frankly useless essay. But if you use a core prompt, say, act as a research mentor, I am working on a cross-sectional study in pediatric sleep medicine. Summarize current evidence on mobile screen time in bullet points, max 200 words. Well, now you're producing a highly usable, targeted draft. Ultimately, it's your own expertise that determines whether the output is actually worth using. That brings us to Section 3, AI in data analysis, focusing on data integrity and the PICO framework. You see, true integration happens right where you already work. Imagine using an AI add-in directly inside Excel. Before you even start analyzing your research data, you absolutely have to audit your data set. You can use an AI tool to instantly identify missing values, flag structural errors, and even audit for logic conflicts. For example, it can instantly spot impossible values, like, say, a recorded age of 350, or maybe a male patient flagged as pregnant. It is an incredible first-pass integrity check that saves so much time. But here is exactly where we have to pump the brakes. Let's say an AI drafts a PICO matrix for you. It might generate something way too loose, like sepsis patients and test NGL. No, the human investigator has to step in and correct that with strict clinical rigor. You have to explicitly define things like adult septic shock patients, testing the renal biomarker urinary NGL within 6 hours, and classifying outcomes by strict key-to-go criteria. AI is an interactive loop, guys. It creates the blueprint, sure, but you have to inject the clinical rigor. All right, Section 4, ML versus generative LLMs. This is the crucial bedside distinction we need to make. Honestly, confusing these two tracks is probably the single biggest risk in this entire field right now. Pay close attention to this. Predictive machine learning is built for numerical drug dosing logic. It's trained on your local hospital's antibiogram and EHR data. It works backward to find patterns, and most crucially, it is interpretable and auditable. Conversational generative LLMs, on the other hand, things like ChatGPT or Claude, they just generate text by predicting the next plausible word. They hallucinate logic. They were absolutely not built for numerical drug dosing. Let me repeat that.
LLMs are not ready as autonomous prescribers. Look, conversational AI is a fantastic teaching tool. It's a great educational reference and an awesome literature assistant to interrogate rather than blindly obey. But it is entirely unsafe as a standalone decision maker for an individual patient. Hallucination here isn't just some theoretical risk, it is a measured, published failure mode. You simply never trust a generative model with live dosing.
Which leads us perfectly into Section 5, the human in the loop. Let's talk about ethical integration.
As we've seen throughout this explainer, research AI is essentially an interactive loop, and you have to actively watch out for traps. First, you set clear goals and put a limit on loop attempts so you don't just get stuck iterating forever. Second, let the AI handle the planning and formatting. Third, and this is the big one, the human must audit for data leakage. For example, if an AI hands you a perfect 1.0 area under the curve score on a clinical regression model, yeah, that's impossible. That indicates severe clinical data leakage or overfitting, meaning it probably accidentally included post-outcome data as a baseline predictor. You have to catch that. And fourth, the human always owns the final clinical conclusions.
When you're following reporting standards, you must adhere to a mandatory disclosure for any manuscript. It usually sounds something like this. Generative AI was utilized strictly for syntax style refinement or formatting. All clinical problem deconstruction, data validation, covariate adjustment, and final text approvals were executed entirely by human investigators. Remember this golden rule. AI is your analytical assistant. It is never, ever a replacement for your own scientific judgment. So as we look to the future of bedside AI, we are really left with a critical, unsettled debate that every single unit is going to have to grapple with before adopting these powerful tools. When an AI-assisted recommendation contributes to a bad clinical outcome, who is ultimately accountable? It is a profound question and one I want to leave you to think about. AI isn't going to replace researchers or clinicians, but those who use AI responsibly will absolutely outperform those who don't. Thanks for joining me on this explainer, and I really hope this gives you a clear, structured path forward.